Okay. So just to recap, what is I.V.T? We have our formal definition. If we have a polynomial function, we'll call this P of X. And we choose 2 points within our polynomial function. We'll call those P of A and P of B. If these 2 points have opposite signs, then we can deduce by our intermediate value theorem that we have at least one value C between A and B for which P of C is equal to 0. What does this mean? This just tells us that we have at least one 0, also known as one root or one x-intercept. I'll go through that one more time, but I'll utilize this sort of visual example below so that you can really solidify this information. You have a polynomial function. The intermediate value theorem states that if you have 2 points on your function, one that's below the x-axis and one that's above the x-axis, by this theorem, we can state that the function has to pass through the x-axis and therefore gives us a 0 they're just using this arbitrary value, but a 0 at that value C. Okay. And so how do we use intermediate value theorem when we're looking at a technical problem? We're given a function, we're given 2 points. If you evaluate what those y values are at those 2 different x value points, you just have to see, okay, well, this one ends up spitting out a negative output. This one ends up spitting out a positive one. So therefore, by I.V.T, our intermediate value theorem, we indeed get at least one 0 that's taking place. Okay. So why don't we practice this? Again, you've seen the lecture video that I created using an example of intermediate value theorem, which was a more challenging example. I have a more straightforward example that we're going to practice right now together from a past quiz that I gave to students this past summer. So what do we want to do here? We want to use our intermediate value theorem to confirm that the given polynomial function has at least one 0 within the given interval. And I put a star here just because we are going to be assessing you guys more on this theorem. So there's a good chance this might pop up on your next exam as well as your final exam at the end of the semester. So once again, what do? All we need to do is evaluate what is our function when x is equal to 2, and then what is our function when our x is equal to 4. If these spit out signs that are opposite of one another, then indeed we have at least one 0 taking place. So wherever you see an x in our f of x function, we're going to just draw in some parentheses. We'll do this in both cases. And then inside those parentheses, for that first row, we're going to put in a 2. And then for that second row, we'll put in 4. And now let's evaluate. 2 to the third is 8. 9 times 2 is 18. So f of 2 gives us -10. 4 to the third is, we know 4 to the second is 16, and then 16 times 4 gives you 64. And then 9 times 4 is 36, so 64 minus 36 gives you positive 28. So what does this tell us? We have a negative sign and we have a positive sign. Therefore, by our intermediate value theorem, or I.V.T, we have at least 1 0 between our x is equal to 2 and x is equal to 4 because f of 2 and f of 4 are opposite signs. Thus, it crosses through that x-axis, so we must have at least one x-intercept. And we're done. A lot of the time, they will ask you to explain, so that's why I put this explanation there. Right? So just a quick recap of intermediate value theorem.